Without any further delay, let me introduce our presenters, Francois Swanepoel and Hendrik Swanepoel. This session will have a potential focus on Archicad workflows from preparation and setup, for scan to BIM to various outputs from the same model and scan data.
Okay. Thank you, Ronald, for the introduction. Just a quick introduction from our side. We are Hendrik and Francois Swanepoel, and most of the Archicad users will know me from the multicad days as reseller, trainer, and support consultant for Archicad. So the webinar, we will have 2 questions and answer sessions. Everyone will be muted during the sessions when we present, and you can always, during any time, just type your questions in the chat in the webinar, but we'll take questions in 2 sections in the webinar. The agenda will cover 2 parts. We'll briefly look at all the requirements for getting the right data from your scan team in regards with point clouds. Our topic is as-built and digital surveys and the workflows in Archicad. And then we will look at practical examples and tips and tricks in the workflow to work with these point clouds and the different outputs that you get from that point. So that's the quick agenda. Hendrik will do the first section presentation. Hendrik, you can swing away.
Francois. Thanks a lot. Hello, everyone. We believe everyone here today know the painstakingly long, inaccurate, and costly process of manually measuring all elements of an existing building with these trusty old tools, right? Okay, perhaps not everyone. Who are the lucky young architects and designers on the session with us today? Next slide. By now, everyone have seen or heard of digital scanning, LiDAR scanners, drones, point clouds, and virtual tours. Yes, these technologies and tools bring a whole new approach to surveying buildings and even opportunities to immerse and engage our clients in much more effective ways, giving us and them more value. Next slide, please. Not all scan solutions are made equal. Different features and capabilities, they all focus on a specific combination of outcomes or purposes. Having a virtual tour of a property from the start is like a magic wand. It not only makes modeling from the point cloud way more efficient, it is also useful for all stakeholders to inspect, measure, comment inside the virtual tour without having even to go to the site. And then, when the project is completed, a rescan is an amazing way to showcase and also sell the project to your buyers. Next slide, please. Starting a renovation project of any kind with a very accurate and complete scan-to-BIM as-built BIM model makes a world of difference in the next phases of digital design and coordination, integrated documentation, and automated design data. Let's quickly look at just a few aspects to make digital surveys and scan-to-BIM as-built BIM models so effective and valuable. It is all about saving you time and money. It's extremely accurate and most complete digital surveys. You get 200% more data from only one site visit. It speeds up studio drawings with point clouds and making on-site surveys safer and faster for your team. During planning and preparation for a scan on site, we look at a few important aspects. Firstly, plan the scan path to ensure all required data is captured. Light conditions for best results, what highlights or info tags and links are required for your project, and important, helping clients to prepare the site or space to minimize time and cost. These are things to look out for during the scan on site for the best results. For example, know exactly what is required. Don't move anything while the scan is in progress or in process. No movement of people or vehicles in the scan area. And also important, if you look on the slide there in the mirror, avoid scan operators in your scan, and by using the right tools for the right job. The processing and publishing requires just as much planning and care on site. Firstly, matching requirements and planning, blurring all private graphics information like faces, car number plates, photos and documents, etc. Finally, preparing and publishing the virtual tour and point cloud files to the client.
Thank you, Hendrik. I'll show the point cloud and virtual tour examples. But before we go there, I just want to highlight with this slide, you'll see these three photographs from the virtual tour, very crisp and clear photographic of the scan area. In the middle, we see a bad point cloud. And on the right-hand side, we see the model as, despite the bad point cloud, the problem was solved. So what Hendrik just mentioned about these key aspects that need to be taken care of by the scan team, this was an example we received by a client, scanned by someone else. That was a bad example of a point cloud. And because of the extreme sunlight that came into that space and not scanning correctly, you'll see in the middle photo a large scan gap with no point cloud to reference the framing. And that just costs more money and time to solve that. It's not impossible to solve, but if the client is paid for a point cloud and they get that result, obviously there's the opportunity was lost to do it efficiently and correctly. So before we go into the Q&A, I want to show you the practical examples of the virtual tour that Hendrik mentioned. And you'll see here a property that we scanned for an as-built purpose. And on all of these camera points, you can literally view all angles 360 degrees. These circles on the ground is the camera points, and you can navigate in the point cloud by means of these circles, and you can skip a lot of them to just move faster. But on all of these points, you get a 360 view in crisp 4K Ultra HD quality. Hendrik also mentioned the measuring. So there's a measure tool, and you can literally measure in the virtual tour. Let's add another dimension. Just go up. So there you've got a dimension. Just note that in the virtual tour, the dimensions is not as accurate as the point cloud. But as you can see, it's accurate enough to get for the owner and for the engineer, for example, or maybe anyone that needs to interact with the virtual tour to get basic dimensions. Okay, so that is your virtual tour. From the same scan, we get the point cloud. And what we've done here is loaded this point cloud onto a Sketchfab online platform to make the point cloud visible to people that does not have the software that we do. So as you can see, if you zoom out, it looks like a picture. And as you zoom in, you'll see the dots. The settings for rendering, you can control the size of the dots. But there's, in this point cloud of this sloping property, as you can see the slope, we scanned the whole site and the 3 levels of the building. We did not use a drone, it was only ground-based, and we scanned the exterior and the interior. So because we didn't use a drone, we didn't get the roof, but we got enough of the roof to make it work. And this point cloud has 10.4 million points. The scanned file was 640 megabytes. So it's a vast area, but the file is efficiently loaded for Archicad. So that's the point cloud. Okay, so now we move just over to questions and answers. If anyone has any questions about the subjects we covered in terms of preparation of point clouds and acquiring point clouds from scan teams.
Hi, Francois.
Brunel, are there any questions in the chat?
All
Yes.
right. Clara said while you were presenting that you missed to say that it also serves as a stock management tool and it records all the fixtures and equipment. So even for a complete building, it serves as a management tool for the real BIM.
That is 100% correct. More so the virtual tour, that is a photographic visual reference. And because we can put info tags into that virtual tour, we can tag anything within that virtual tour. Sorry, that's just my UPS going. I don't hope it's disturbing you. So yes, that is very true. Looks like I can carry on, Brunel.
Yes, you can.
Okay. So now we move into the modeling side of the as-built. The scan has been delivered. The virtual tour has been delivered if your scan operator do give you virtual tours. So what is important to consider when you're ordering a point cloud from a scan team is you need to understand and know and communicate to them very clearly what it is that you require. What is the purpose of the scan or the point cloud that you require? And that is determined by the level of detail that you will need to produce in your as-built model. Do you need all the furniture in full detail? Do you need all the sanitary ware in full detail? Do you need all the window frames with all mullions in full detail? Or is that not a concern? If you're going to replace all the windows, just the outline will be sufficient, or your window reveal will be sufficient, for example. So do you need a highly detailed, accurate digital twin at the end of the day? That will determine how much care and extra time needs to be spent in scanning the source data that you receive in order to produce the as-built model to that level. Are you going to produce a super realistic render from your model? And how much information is required in what level of detail? Skirting, cornices, all these fine things. Are you going to collaborate on your project? So that will determine also how this point cloud is delivered and formatted. So maybe you also want to offer additional services and aspects to your project. All these things need to be communicated to the team, both the scan team and the modeling team. In this practical workshop, we're going to look at how to get more from your point cloud and the modeling process. Loading the point cloud into your Archicad, viewing and navigating inside the point cloud while you're working accurately, and how to model fast. Don't forget the virtual tour, and use the virtual tour to understand all the spaces that you are working in the point cloud, and then just basic tips and tricks. Before we go into the actual workshop, here's just a few additional background about how Archicad deals with point clouds. You'll refer to the point cloud troubleshooting guide in the Graphisoft community site. There's a lot of information about how Archicad works with point clouds and the things that either limitations or issues that you may come across. It was started in 2016, been updated since by Graphisoft's team. So the most important thing there, and most common question we also receive, is Archicad has a limit in how big the point cloud is that you can load to Archicad. That file size limit is 4 gigabytes. So that's the file size. And we use, on the right-hand side, we take the same project that we'll be working on and that you saw in the virtual tour and point cloud. That file has a native format, which is an XYZ or an E57 file. The XYZ file that the scan produced was 653 megabytes. So it's far within the 4 gig limit. But when you load that 653 gig megabyte file into Archicad, Archicad converts that point cloud XYZ file to an LCF library file. And that library file is 152 megabytes. And that is the file that Archicad has the 4 gig limit on. If we calculate it backwards, this 10.4 million points in this point cloud is converted to a 152 megabyte file. And in the end of the day, if you calculate backwards from the 4 gig, you'll end up with a 276 million point cloud, resulting in a 17 gig XYZ file. So that is your benchmark then If you receive an XYZ file, which is in 15 gigs, it's very close to the limit. If the point cloud is about 270, 280 million points, you are very close to Archicad's limit. So that, if we translate this then to the same project and multiply it, it means that you can have the similar building with 25 stories instead of the 3 levels that we have here. Just to give you an idea of the size of the building that you can possibly have. Okay. Now we're going to quickly look at, just briefly look at where this data can go. You start with the scan and of point cloud and the virtual tour data set. You take that into Archicad and produce, model your as-built. But from that as-built model and scan data, where can you go with that data set? Obviously, your design and your documentation for your project, working with Archicad, BIM Cloud, and publishing it to BIMX is the common ground and the main area that you work within. But you can receive your point cloud data from different scanners, Emerson, Faro, Leica, Trimble, and even drones. You can do feasibility studies using Archicad and TestFit and Archicad in combination. In your design process and your documentation process, you can then coordinate with other stakeholders from your project via IFC to Celebri, Revit, and even then do computational design through Rhino Grasshopper, energy analysis and simulations through Smart XA from BIM Bakery, Ladybug tools, and the likes. In your construction phase, your model will still be valuable in that process if you use it right. Forecasting, planning, project management, collaboration processes for reporting from site to the office via BIM Colab, Bluebeam, and even then also via progress scanning with OpenSpace from Agile in Cape Town. On the marketing side, you can obviously use your BIMX to help clients and buyers visualize the project, render into InMotion and Atlantis, and even take it further via Unreal Engine Unity. The Matterport comes back in the marketing side of things by means of when the project is complete, we rescan the project and you have a virtual tour in full 4K of the completed project for marketing purposes. And then it goes even further into VR, AR, and XR through Archeo and Inkscape, and then even into metaverse platforms like Spatial and Decentraland. On the operations side, for facilities management, there's a few solutions that has direct or indirect links with Archicad, where you can transfer your data into that environment. Okay. So the few examples that we prepared for you to look at is then the virtual tour. You've seen that the point cloud, you saw that on the web browser. We'll show you in Archicad. You'll see the as-built process and the different tips and tricks in terms of working with it. Quickly showing the Smart XA analysis capabilities that you can take your model through. BIMX, everybody working with Archicad knows BIMX in terms of visualization, communicating with contractors and consultants and clients. I'm going to quickly show you these examples of Twinmotion and OpenSpace and Archeo and Spatial. So when we talk about Twinmotion, what you see here is a panorama set So it's rendered from an Archicad model into panoramas and then published to the new Twinmotion Cloud platform. And you can set up your different views and then teleport and navigate to the different panoramas where you can actually have a 360 view of your rendered scene. You can also just click on the hotspots in the scene and you can navigate to those hotspots, and you'll see you can render in different scene modes. So that is one of the outputs quickly. When it comes to construction management, your BIM model, which you see on the right-hand side here, can be loaded and linked to a scan on site for construction progress. So you can see that this interface on the open space platform gives you the ability to inspect the actual site by means of the photo scan on the left and relate that to the model on the right hand side that you publish via IFC. And I'm just switching off these quick layers here so that you can see the duct work inside the scan on the left hand side, and you can then compare and check your work on site according from the model. So when you go to spatial, I'm just going to load this same project that we rendered into Twinmotion, and it will take an extra second to load. Okay, there you see an avatar, and you can literally walk through the place like in a game. You can have a first-person viewing mode and walk through your model. But the main thing about this platform is you can take your project into this platform and have virtual meetings with your clients, and everyone will move around and interact with the space by means of their avatar. And you can inspect, have your design review. In a virtual meeting, everyone can talk. There's means of putting sticky notes on the model. So there's way more things that you can do with your model. So let's get back then to our first project and loading within Archicad. So let's start with loading a point cloud into Archicad. The menu path is File, Interportability, Import Point Cloud. You select your point cloud file, in this case XYZ, and you can see Archicad can take E57s or XYZ. Okay. The default settings is works for 90% of the cases. So we're not going to cover those advanced cases where you need to interact or change these settings. You can accept the defaults for most cases. Archicad will ask you where to put this file. So you need to browse to a folder and give it the path. And I find it's good practice to give the LCF file that Archicad will create now, give it a name relative to the project. Okay. And there's two options then following. You can create in place. And this is the option that you use when you are working with a PLN solo project. When you are working with a teamwork project, you'll first need to create this LCF file within that file location that you designated for it. And then with the Archicad interface, upload the LCF file to the BIM cloud. And then in your team mode file, you go to your library manager and then link that BIM cloud version of that LCF file library into your libraries. So just as a reminder note, the create in place is for PLNs, and the create is then the best workflow for team mode files. We're going to create in place. Takes a few seconds. While this is happening, just want to highlight, depending on the device that was used for the point cloud scanning, some of these devices have the capability to geolocate that point cloud and others don't. So just make sure what you are receiving from your scan team. With Archicad, in the project preferences, you can set your location, the exact GPS coordinates. So it's best practice to set your GPS coordinates before the time in your file, so that when this geolocated point cloud is loaded, by means of the default method, it will automatically link with that geolocation and match the location correctly. Just waiting for the last section to load. So what Archicad is doing now, taking the XYZ file, converting it and compiling it into the LCF file, saving the LCF file, and now it's loading the LCF file into the library. And then it will give you the placed point cloud file into your Archicad model. When placing it, Archicad now asks you, what story do you want to place it? Do you want to have a specific location for it? We're just going to accept the project origin. Like I said, the origin has been set preferably. And when that is done, you can just take the default option at the top and say, just place at origin. After the placement, you can relocate and move the point cloud around. Another thing, when in terms of your template, the Archicad template that you load, your own or the default, has story settings. And I just right click on the tab, go to story settings, and the height of this story, of each of these stories, may not match the surveyed data. So what we'll do is, once the point cloud is loaded, as you can see here, if we zoom in, you can see it turns into points, and you can measure between these points. And in this case, we've got 25 millimeters on this point grid. You're zooming out, you can start to see the place positions of the walls, maybe furniture, cupboards. When you zoom out, it starts looking like a picture, because each of these points has X, Y, Z coordinates, as well as a color code, which helps with navigating in the point cloud. A point cloud, which is just black and white, is way more difficult to work within than a point cloud that has colors. And as we said before, the virtual tour makes it even better and easier to work with. So you want to have one section at least going through your point cloud in different directions so that you can start measuring. We're just putting one down the middle here. Initially, you want to set your section to have a limited depth. What I mean is, the default for Archicad is for the section to have infinite depth, So it's from that cutting point, it's looking infinitely far. What that does is, I'm going to show you before I change this, so that you can see the difference. Okay, so now there we are on the section, and we can see firstly that we can see, I know this point cloud, so I can see this is the stairs that we have on the plan, where we cut through on this section. Come on. And we can see all the way to the side boundary wall and the trees in the background. And that's too much information. We can even see what looks like a picture in this room is actually a picture in the background. So when you start, you need to now then filter these. Also, I can see that this point cloud is not vertically positioned correctly, and you need to then move the point cloud with normal drag command, refer to a point in that point cloud that is representative of the floor finish, and you can then move that upwards to match the true ground story. Okay. In this case, we can now also then start setting the story height correctly. We then measure from the story line after correct placement, and then we measure to the top floor finish there, and this tells me that the story height floor to floor needs to be 3205. Okay, and you'll see that the storyline for the next story there is one story too less, plus also it's not at the correct height. So we go to our story settings, taking the shortcut from the story tab, insert above while we're busy with that, insert that story. We measured the ground story to be 2305, and you'll see the section update, additional story, and the storyline is now correctly in the correct height. I'm just going to also, while we're busy with this, measure to the ceiling. And if you look at these point clouds, you'll see indents going up, some of them going up, but there's a common line that starts to appear within the point clouds. And it's this line here. So you reference that point there for the height, of the ceiling height. That's 2679, 2697. And we can adjust that. I'm just going to zoom up so you can see it respond. 2697. And you'll see your storyline adjust. So this is one of the first things you want to do. Next thing you're going to do is then set your section depth to limited. And you'll see points are being removed in the background. You can go to your plan. And set that it went to the first story there. You can change the depth of the section in the plan. Just pull that in. Make it about 500. It's a good depth to work with. And you'll see your point cloud then starts to show you the actual area that you are working with. Another way to clear point clouds is to use the cutting planes in the 3D window. So you just bring in your cutting planes and crop out the area that you want to work with. And in that way, you've got a clear area that you work with, and you can focus your modeling and work faster with less point cloud data that's in your way and confusing you. Okay, so that's about the loading and the setup and navigation. We're going to next look at that completed project. Starts to getting familiar for you now. So here we have that completed project. The view that I have here, different views that I've set up. So here we see the point cloud and the model together in this window. And as you can see, the point clouds, how they sit on the surfaces, or actually the model has been modeled in accurate proximity to the point cloud. Okay. So that goes for everything that was scanned and picked up by the scanner. If we go to the floor plan, and let's go to the top story here. You'll see this as being where the point clouds actually show up around the model. And just like we did on the section, you'll measure the point cloud where it shows you where the walls are. In this case, you'll see a stacking folding door. When it was scanned, this area here is where the stacking door was in the open position, only the opening leaf, and these other were closed. In this area, you'll see a blank space on this side of the passage wall, and that would represent a cupboard. So let's go and have a look at this area. I'm just putting a 3D marquee around, going on F5. So this is also another quick way to limit the view that you are getting and in terms of the area that you work with. And you'll see that there is point cloud in this area that shows a cupboard coming up from this distance away from the wall. There you can see the opening leaf, point clouds that show that stacking door open leaf. Here we can see the point clouds just below the ceiling, and it looks like they are bulging out. Obviously, Archicad's native slab elements is flat, and this tells you if you go on this side, you'll see where there's no point clouds there sticking below, there might be point clouds sticking up. So this ceiling was not fully flat, and it was bulging and heaving up and down. So you'll use this to very accurately model those aspects. If they are skew, model them skew, because when you start designing, that will make a big difference in your accuracy of your dimensions, and make the contractor work on site much easier because you're getting accurate dimensions to start as a starting point. Okay. In this completed section, again, I'm going to familiar areas so that we don't get confused with all the point clouds, so that you can follow along. But as you can see here, how the model was done within this area. Okay. I use the wireframe model view. It's a special view that I've set up in my Archicad, so that I can see the point cloud and then a wireframe only model. Sometimes this really helps with finding the right point clouds when you are modeling, to have this view set up. So what I do here is I select the layers and make them all, switch them all to this wireframe icon, which then effectively makes the whole Archicad 3D model components, elements then in wireframe. I have this blue pen set that has everything in blue, as you can see there. And then I get this view, which clearly differentiates in terms of the color coding, what is model and what is point cloud. And you can reference with deeper reference into the model by means of this. So as you can see, sometimes you'll work with a point cloud and solid model, and sometimes this wireframe model really helps you a lot in terms of working more accurately with your model. Okay. I'm going to move over to another project, and this project is a farmhouse, and we're showing this project because the farmhouses being 60 plus 80, 90 years old, they've got these 600 thick walls, some of them with mud bricks. So these walls are never straight, they're not even upright. So, and that makes a difference when you're modeling. So having a look at this wall here as an example of that, you'll see the point clouds sitting, the wall and the point cloud sitting very nicely flush with one another. But what you don't see with a clear eye is this wall is actually leaning over. And as you can see here, the wall is leaning over by 0.86 degrees, call it 0.9 degrees, nearly 1 degree lean over. And plus also to note that this wall is only going to the loft and ceilings floorboards. This client wanted to renovate and upgrade the roof space to become usable rooms. And we needed to model this obviously accurately. And if I change this to an upright wall, you'll see that wall move to the outside. If I select the short wall of the next story, you'll see that there's a distance in difference. So I know this model, it's about 75 millimeters, 80 millimeters in places. If you add that 80 millimeters to the other side as a fault, in quote, it will mean that if you just model straight up, ignoring the point cloud lean over, your model will be 180 millimeters, 160 millimeters out. And that's why it's important. And it also proves the point that point cloud scans has so much more data that it makes it possible for you to pick this up, which you cannot pick up by measuring by hand. It's simply not viable to spend so much time on site measuring by hand to get this level of information. So the point cloud, this property was scanned in a matter of 2 hours. And if I just switch off the cutting plane, get a quick look at this project. So it's not a very big house, but it has these outbuildings. It's already got the staircase going up to the loft. Mostly these old places, the loft space was used for storage and is now being converted. So if you're measuring this property inside and out, in the roof space, all the rooms, it's going to take you a very long time, and you might need to go back several times and not even finish in one day. All this data is captured by means of a point cloud. So point cloud is obviously way more efficient than measuring by hand, even if you are using a laser disc. So as you can see here, we're just coming into the point cloud and where the beams are being modeled to follow the point cloud. These beams are not parallel to one another. We'll just quickly go moving to the plan, and then you'll see how these rafters are not parallel. And we could model according to the point cloud and get that accurately because of the point cloud, which in other cases, to get all that dimensions and getting these beams at the right place so that the architect and engineer can do their design work accurately enough, knowing which beams to keep and which one can be removed. I'm just struggling to get to the view. Sorry for that. And we go to roof. So hiding that layer. And here you can see, if I just bring in a reference line, guideline, that these beams are totally out of parallel, but we modeled them according to what the point cloud said. So from this model, we are learning that taking care and using the point cloud to get a fully accurate model does and can make a big difference. So similar scenario is for these floor-bearing beams. Okay. And then obviously for items like the columns here, Victorian columns, and the curved roofing, we could accurately produce that, right? Okay. So that concludes our modeling part, I'm going to then just quickly show this example of a project that was done with point cloud scanning to begin with. It's a renovation project, and what we see here is a renovation project that already has the new parts of the building done. This project was submitted to council, and I'm just loading the point cloud along with the new design and existing. And as you can see there, a point cloud of this model. And then at the end of the day, council drawings were done, and then also the SANS tour for energy compliance analysis and calculations were done, showing the compliance and all the calculations directly from the model, instead of Excel spreadsheets, manually capturing all this base information into spreadsheets. It's all done by the Bakery Smart XA tool, and the workflow is really, really easy. If you look at the window, for example, there's very few things that you need to do on this model. And it starts with assigning the XA marker, dimension marker for the window, instead of the standard window markers in Archicad. Designate to the Smart XA marker. The edition 2 has been released and it's tested. The orientation is being picked up automatically for you by means of this tick mark. You designate the frame and glazing combination from the table, and after measuring, physically measuring in the section, the P and H values, you enter them here, and that basically takes care of the settings and your interaction with the model for the analysis then to happen. In addition to that, you'll place zones and for area calculation basis, and that's basically in short, the setup, and Archicad will do this for you, right? Renelle, how are we for time at this point?
I think we're roughly on an hour.
Okay, right. So we'll just quickly revert back to the slides just to check that we went through everything that we wanted to show. You see that loft project, and there's just more projects that was completed. And just to summarize at the end, how to get started with an as-built based from point cloud for your renovation projects. You need to know exactly what you want, what you need, and why you need it. Get the right service provider for your project and the purpose and the location of your project. Give your scan and modeling team an exact brief. This exact brief, I can't emphasize this strongly enough, will definitely save you money if you do this diligently. So proper planning and preparation, then, as we've highlighted, have all developed the right skills. So those can be outsourced skills that you can acquire from different service providers and us, or you can develop the skills, the modeling skills, and maybe in some cases even the scanning skills in your office to do this workflow and get the benefit from this data, and then deliver your projects with confidence and leverage your BIM model as an asset. So thank you very much, everyone, for your time and attention. We'll then just switch over to Q&A for the modeling part. We are welcome to take your questions.
Francois, can you give us an idea of how much it costs? Yes. Can you give us an idea of how much it costs to scan?
Yes, I can give you some ideas. There's a few factors. Let me start like that. There's a few factors driving the cost of the scan. So obviously the logistics of having to travel to the site. We've got there's people across the country that can scan for you. We've got 9 people across the country that we can send from the closest proximity to the site. So traveling is a factor. How big the building is. If we can't scan the building in one day, if it's a large building, say 5,000 square meters, that might take us 2 days to scan, 2-3 days to scan. That's a factor. But in general, we're talking roughly, okay, depending on the scope. How much detail need to be scanned also determines this. But just taking this farmhouse as an example, I can tell you what the cost of this was, more or less. The scanning was about 9,500 Rand. And that then excluded the modeling. We did the modeling for this architect as well. And that's also driven by level of detail and the scope of the end result. In this case, we needed to model the windows according to the actual mullions of the scan. As you can see, these columns and the bruculace, all these things were modeled according to the scan because they needed to be accurate. All these columns can be derived and accurately produced. So that's all detail that goes into the scan and then also into the modeling side. These are factors driving the cost. If we need to scan into roof spaces where we need to capture MEP systems, then obviously that's a different, separate additional scope that will also drive cost. But this scan, you can literally see what the scan was. This was roughly 9,500. Does that give you an idea, Clara?
Yes, it's fine. Thank you. It's cheap. Bye.
I'm happy to hear that. It really is cheap because of its efficiency. This scan literally took 3.5 hours to do. The complete building was surveyed to 13 millimeter accuracy with all this data in one go in 3.5 hours. So the fact that we use clever tools and stuff, that doesn't make it more expensive. That's the whole idea. It needs to be more effective, cost effective, time effective, and more accurate. And that it delivers on all of those. How long does it take to scan a farmhouse like that? I just answered that question. I see in the chat. Are there any other questions?
Hello.
Hi, Zane.
Hi, yeah, thanks. So we're a bit late to join in, but what format does the file come in into Archicad? Is it an IFC or what?
No, the raw scan file that Archicad can load is an XYZ or an E57 file. So those are the two file types that you ask for when you're sending a scan team out.
Sorry, just to confirm,
there are ways to convert.
Depending on the density of the points, did you find the file becomes cumbersome and large? Because I know we've used on one particular project previously, and it wasn't that useful. So I just want to know how you deal with the size of the point clouds.
Yeah. When we process the point cloud, let's say this is a 80,000 square meter building, multi-story building. That'll produce a point cloud of a raw point cloud of about 30 gigabytes. But that 30 gigabytes loaded, I'll just bring back up that slide here. We did have a discussion about that on this very slide, about the file size. So here's a calculation that you'll refer back to the recording when we discussed it. Now that if you missed that part, there's an article on the Graphics of Community site for point cloud troubleshooting, stating that the file size limit, once the point cloud is converted and loaded into Archicad, that LCF file, that Archicad LCF file, has a limit of 4 gigs. That means if you, by means of this calculation, you'll get a point cloud of more or less 276 million points, giving you a 4 gig LCF file. But the raw file before conversion is 17 gigs, for example, on a file like that. So I don't know what the file size is that you have received in the format, but if the file is too big, and if it's been scanned with a Leica or a Faro or something like that, which is very high density at 6 millimeters between points, it captures way more points than Matterport and some other systems, way more than is necessary. That point cloud can be what's the word I'm looking for? In the processing, that point cloud file can be reduced to have less points, but it's still accurate enough, giving you enough data so that you can still measure with accuracy for a building. So Thanks. When the point cloud is too heavy, ask your scan team to compress the file or remove some of the points.
Thank you everyone for attending this evening, and thanks to Francois and Hendrik for making time to deliver this presentation. I'm sure many of our attendees gained a lot of insight from your session.